Hey, my name's Loeskow, and today we're going to talk about stress and strain. When external forces are applied to objects, they produce a change in shape and size of the object. For example, when this ball hits the ground, it has the force of the gravity push and the force of the ground acting against each other, and that produces the change in shape of the ball. Stress is the force of the material, and in simplest format it can be referred to tensional, where the forces are acting away from each other, therefore the forces are actually stretching the object, and compressional stress, when the forces are acting against each other, and therefore the forces are trying to squish the object. Stress is a measure of the internal reaction of the object while experiencing an externally applied force. Therefore, it's the reaction inside the object. Here's the formula for stress. Strain is actually what happens to the material under a given stress. In this diagram below, we have a spring with a mass attached to it. Gravity is trying to pull the mass downwards, and therefore the spring is then stretched. This extension of the spring, we can use this extension of the spring to then determine the strain. Strain is a measure of how much the material or member will deform under the certain stress. Here's the formula for strain. Like I said before, we can use the extension or compression to then determine what the strain is. Here is an example that I hope will help you understand more about stress and strain. The diagram to the right illustrates an elephant weighing 80,000 units on a pillar. The original height of the pillar is 6 meters, and when the elephant climbs on, obviously having a crane or something, is reduced to a height of 5.9 meters. If the radius of the pillar is half a meter, calculate the stress and the strain of the pillar while supporting the elephant. Here's a solution to the question. We don't currently know the area of the base, but we can find that by using the formula pi r squared, which is the formula to find the area of a circle. We can then use all this data to then sub it into the formulas we discussed earlier. And this then gives us a stress of 101.86 kilopascals and a strain of negative 0.016 units. Strain has no units. Therefore, the pillar experiences a stress of 101.86 kilopascals and a strain of 0.16 while under compression. The strain was negative coming out of the equation because the pillar was under compression, but due to a sign convention we know that this is positive under compression. Here's a figure which illustrates stress and strain with different materials. Material A is the strongest and stiffest material. We know this because it undergoes a lot of stress with a high load and hardly has any strain, therefore it doesn't stretch or compress much at all. B is the most brittle because it gets to this point and then suddenly breaks, compared to A, which has a higher strain and breaks at this point. Material C is the most ductile because it has a breaking point of at a very high strain, and with the stress compared to strain we know that it is fairly elastic. D is more elastic, but it has a lower breaking point compared to the strain, referring to strain. I hope this lecture has helped you understand a bit more about stress and strain. Thank you.